Okay, this last section of conics is the hyperbola, and the equation looks a lot like an ellipse, so the difference is the minus instead of a plus right here. Other than that, these equations are the same thing as an ellipse. HK is still going to be the center, but this time, instead of this thing folding in on itself like the ellipse did, it's going to expand out to infinity along these asymptotes. The asymptotes are given by these equations. They're very similar. The only difference is b over a here and a over b here. I'll show you that with the drawing. Center, like I said, is still hk. And then this time it's a squared plus b squared equals c squared. And again, it's not that the Pythagorean theorem changed, it's just how they labeled it changed. And so this time C is going to be actually the biggest of the numbers, and A and B would be the legs of the triangle. This distance right here would be C. A is center to vertex, so the vertex now feels more like a parabola, but we have two of them, one on each side. It also sort of defines this side of this box. B, what used to be the semi-minor axis for the ellipses, now it's kind of the center to the other side of the box. And then what we do is we draw that box, and that lets us draw in these asymptotes that were given the equation down here. And then C is our center to our focus. And then just like the ellipse, they have two flavors. They have the one where the transverse axis, that's this thing right here, runs along X, and one where the transverse axis runs along Y. So kind of all the stuff is happening X, or all the stuff is happening Y. So same as the ellipses. And just like the last two sections, we start off centered at the origin, and then we'll kind of work our way through the variations. So let me get this graphed. So find the equation and asymptotes this time of a hyperbola with a focus at 0, 5. So x is 0 and y is 5. So that would be right there. A vertex at 0, 3. So that would be right there. And a center at 0, 0. So vertex, focus, and center. And so if I have those 3 points, then that means I also have these two. There's the other focus, and there's the other vertex. And then that also gives me A and C. So A is still center to vertex. Oops, you know what? I mislabeled this one up here, sorry. Actually, I mislabeled both of those. Let me fix that. So this is the vertex. Sorry, I just did the ellipse video, so I have to shift gears out of ellipses. And that's the focus. So this is the vertex, and this is the focus. So A is 3, it's center to vertex. And then C is going to be center to focus, and that was 5. And so I can say 3 squared plus b squared equals 5 squared, or b squared equals, that'll be 25, bringing the 9 over, minus 9, or, scoot up here with it, b squared equals 16, or b equals 4. So once I got that, now I can come over here. So here and here would be the B. So notice in this case, A doesn't have to be the big number. A can be actually, in this case, the smallest of the 3 numbers. It's going to be one of the 2 smaller ones, because for these, C is always the large one. So then I'm going to draw in this box. And then if I could draw straight lines, this would represent the asymptotes of the hyperbola. So something like that. And then the actual graph is like not very precise at all. It's just be kind of like this going through the vertex, and up here it'd be kind of like that going through the vertex, and then just staying in those asymptotes. And so just to kind of cover these one more time, this distance right here was A, and so that's our center to the vertex, center to the focus, and then that was C, and center to the other side of the box, that was B. And then just remember to draw, I don't know how many times in my notes I've had to like try to white out where I drew these going the wrong way, but they should go through the vertex. Then to get my equation, so let me come back and grab this page for a second. There's one other thing that was different with hyperbola. In this case, the a and the b stay put, so it's the same in both equations, but it's this minus sign that changes it up. So if it leads in x, everything's along x. If it leads in y, everything's along y. And this is another one where our k and our h are going to be zeros, so I can just have those drop out. So this will be y squared over a squared, and a was 3, so squared makes 9. And then minus this time x squared over b squared, so that'd be 16, equals 1. And then the equation of our asymptote was y minus k equals plus or minus a over b, x minus h. And so let me just fill this in and I'll show what that means over here. So again, h and k they're actually going to be like our left-right shifts when the center moves, but in this case they're 0. So this is going to reduce to y equals plus or minus 3 over b is 4. So 3/4 x. And if we look at this, this is our slope. Here's our a, and a is our rise, and b is our run. So that's why it's a over b, rise over run. So it's running 4 and rising 3. And then the minus is because it's also running 4 and dropping 3 for the second one. So there's our equation of our hyperbola and the equation of the asymptotes. Okay, for number 2, we have find the equation asymptotes of a hyperbola with focus at 7, 1. So then x is 7. 7, negative 1. Y is negative 1, so that'd be right there, and that was a focus. A vertex at 6, 1. So that's right there, vertex, and a center at 4, negative 1. So right there's the center. So if I have those points, that means I also have A is 2 and C looks to be 3. So there's my other focus and my other vertex. So this is going to be going, these will define the box. So like I said, A is 2 and C is 3. So this will go 2 squared plus B squared makes 3 squared, where B squared equals, that will be 9 minus 4, which is 5. So B would be root 5 for graphing purposes, or about 2.2. We can get our equation from there. There's our H and our K for our center. This one is going to be, everything's happening along X, so it's going to be this version. And so our formula, and this time I'll write it out since I have more stuff to plug in. X minus H squared, A squared, Y minus K squared, B squared equals 1. And so kind of getting all this stuff set up, we got X minus 4 squared, and that is over A squared, and A was 2, so this would be 4. And then minus Y minus K, and K was negative 1, so that'll show as a plus 1, over B squared, and B squared was 5, and that equals 1. So, I might as well grab the asymptotes too. So the asymptote equation for this is Y minus K equals plus or minus B over A this time, so that's the part that reverses, because now B runs up and down as the rise and A is the run, and that's X minus H. So I was just grabbing from right here. Y plus 1 equals B, which is root 5, plus or minus root 5, over A was 2, and then X minus 4. And then finishing getting the graph of this, this was 2.2 or so, so the other side of the box would be about here and about there. And so it looks something like that. And then if I just try to draw kind of a straight line through the corners in the center, those would be the asymptotes. And like I said, the graph itself isn't too exciting. It's just sort of a little swoopy thing right here, and another one on this side. And then in terms of this equation for the asymptotes, what this says is it went from the center, it went right 4, and then plus would be down 1, and their slope is going to run 2 and rise root 5, or run 2 and drop root 5. So this is just a transformed version, transformation version of the equation of a line. Number 3 is pretty similar. And you can certainly stop the video, try this thing, and then see how it goes. I'll go ahead and do it here. So getting things graphed, I have focus at -2, x is -2, and y is 4. So that's right there for focus. I have a vertex at 0, 4, so that'd be here, and the center at 1, 4, so I'll be there. So again, that lets me fill in the matching points on the other side. It'd be like that. And then from that, I can tell A is 1. So that's center of the vertex, and C is 3. And from there I can get B. So 1 squared plus B squared makes 3 squared. So B squared equals 9 minus 1, or 8. So B equals root 8. And again, that was about 2.8 for graphing purposes. So I'll finish up the graph this time. So 2.8 would be just under 3 and just under 3. Oops, and I drew it in the wrong spot. So here and here. So there's the box, and then the asymptotes would run just like that. And then the graph would be kind of this very shallow, kind of like that. Okay, so then to get our equation, our center was at, that's our HK right down there. So this one, everything's transverse x, so we'll lead x. So x minus 1 squared, and that'll be over a squared, which is 1. And then minus y minus 4 squared over b squared, which was 8, equals 1. And then for this one, the asymptotes are y minus k equals plus or minus. It'll be b over a this time, and x minus h. So that is y minus 4 equals plus or minus b over a, so that is, b isn't 8, it's the root 8 over 1, so I won't write the 1, and then x minus 1. Oh, you know what, since I'm actually using this number, what I should do is reduce it, so, or simplify it. So this is a 4 times 2 in there, so that's going to be 2 root 2 x minus 1. Okay, so for this one, now we're given the equation and asked to find the stuff. And so, since this is 4, a will be 2, and this is b, so b will be 3. It's actually b squared, sorry. So then 2 squared plus, 3 squared equals c squared, so that'll be 4 and 9. 13 equals c squared, or root 13 equals c. And that would be about 3.6 for graphing. And so we got that. The center, we already know, it's kind of sitting there looking at us. So the center for this is going to be, careful again on the order, so it'd be positive 2 and negative 3. So they wrote it in the opposite order because the y's are leading, and then you gotta remember to change the signs. So from there, I think I'll start graphing, and that's going to help me get the rest of this. So I have a center at 2, negative 3. And this is leading in y, so that means all my stuff is going to be running up and down y. So A is 2, that will be here. And then B is 3, so that will be out here. I'll go ahead and draw the box. And then the C was 3.6, so that's our focus. That's going to be off the vertex. We'll go ahead and draw on our graph. And then 3.6 off the center would be, maybe there. And then 1, 2, 3, about there. And so then to get those points, the vertex we can just read off the graph pretty easily. So 2, -1, and then 2, and I think that's -5 down there. And then foci, that's going to be, so you can kind of see how the 2's are repeating, so everything's along 2. And then we're going to start from our y value on our center, and then just do the same thing, the plus or minus. So it's starting off at -3, and then we're either going up or down root 13. And then for the asymptote, it's going to go y plus 3 equals plus or minus rise over run. And so this time the rise was 2, and the run was 3, and so that's also a over b. And then the x, so x minus 2. Okay, and then the last one of these. So this one isn't quite in the right form, so I'm going to do a little bit of work to get it there. And so this is going to go x squared minus 2x, and I think I'll just write it in order first again. So y squared minus 2y, and that -1 I'm just going to kick over here and have as a 1. So then I'm going to have to complete the square in x, so I'll rewrite this. I'll leave myself some space. Here's the tricky bit here. It has to be inside the equation. It's a positive y, and the minus really belongs outside. So I'm going to factor out like I'm factoring a -1. I'm leaving myself space though. So y squared plus 2y, and leave a little space there, equals 1. So then completing the square, half of 2 is 1, 1 squared makes 1. So plus 1, plus 1. And for y, again, half of 2 is 1, 1 squared makes 1, but it's not really a plus 1, because if I distribute that sign through, I can see it's really a -1, so there's a -1 right there. So a couple of those just cancel out. Factoring, this is going to be x minus 1 squared minus y plus 1 squared equals 1. So what that means, and we didn't see this with ellipses, but it means that a equals b. They're both 1. In that case, for an ellipse, it would have been a circle because the semi-major radius and minor would have been the same. But so, with the hyperbola, it can happen. I think for you guys to be able to see this, I'm going to kind of, instead of using one box, I'm going to have the heavier line be 1. So I'm going to count that as 1. I'm going to count this as 2. And have this be -1, -2, just to kind of blow it up and make it a little bit easier to see. So right here we'd have the center at, this would be 1, -1, opposite signs. And then A and B are both 1, so we just get kind of this box right here. And then this thing is leading in x, so that means it's transverse x, so everything's happening parallel to the x-axis. And so that means my graph, that means this is a vertex, and this is a vertex. And my graph's going to look kind of like that. And then, oh, I never did find C. Let me grab C out of there. Actually, I guess I could do the vertices first since I just did those. So let me finish that idea. Vertices, so we got one at 0, -1. And we have a second one out here at 2, -1. And then to find C, we do a squared plus b squared equals c squared. So 2 equals c squared, or root 2 equals c, and that's about 1.4. And so c would be, if I did this as 1.4 would be about here and about there for my foci. And then getting those coordinates. So that's going to be, here you can kind of see everything's -1, so we're going to work off the x. So we're starting at 1, and we're going plus or minus root 2. And then -1. And for the asymptotes, that's going to be y plus 1 equals plus or minus, in this case, a and b are both 1, so it's just plus or minus 1 over 1, which is 1, obviously, x minus 1. There we go.